Mountains shattered, secrets exposed, Operation Midnight Hammer sent 7 B-2s and the 30,000-pound MOP into Iran's deepest vaults. Proof that brute force still works, but only barely. Now, the US Air Force wants smaller, smarter penetrators. Glide release, void-sensing fuses, GPS-denied guidance. The next war may be underground. Stealth, precision, and new physics will decide who controls the deep and future doctrine. In June 2025, the United States Air Force carried out one of the boldest strike missions in recent memory, Operation Midnight Hammer. 7 B-2 Spirit stealth bombers penetrated Iranian airspace to strike underground nuclear facilities suspected of hosting uranium enrichment operations. The weapon chosen was the GBU-57 Massive Ordnance Penetrator, or the MOP, a 30,000-pound ordnance crafted to defeat the most hardened subterranean targets. Developed under the early 2000s Big BLU program and retained in reserve for years, the MOP made its combat debut during the raid. At more than 20 feet in length and weighing roughly 13.5 tons, the munition is capable of plunging through 200 feet of earth or 60 feet of reinforced concrete, delivering kinetic energy comparable to a heavily laden airliner at touchdown. According to a report in Scientific American, the kinetic strike delivers 800 to 900 megajoules of kinetic energy, comparable to a 285-ton Boeing 747-400 touching down at 170 miles per hour or a 565-ton Amtrak Acela train moving at 1 to 20 miles per hour. The strikes produced dramatic surface effects. Fordow, the most deeply buried site, required a concentrated application of fire. Analysts say 6 MOPs were expended on a single aim point, each successive impact boring deeper until the facility's hardened layers were breached. Satellite images later revealed multiple large craters on the mountainside. Experts judged that vibration-sensitive centrifuges used in enrichment were likely rendered inoperable.
Now that we know it worked, I'm certain our adversaries are already looking for ways to adapt. We are preparing for the next steps to stay ahead of them.
Yet the mission also exposed constraints. Other sites, notably Natanz and Isfahan, absorbed heavy damage but displayed resilience. Some underground sections may be repaired sooner than officials hoped. Operationally, the MOP's sheer mass ties it to only a narrow set of platforms. The B-2 can carry 2 per sortie, necessitating complex force packages. More than 100 supporting aircraft were involved in suppression and support roles. Those next steps have now taken concrete form as the Next-Generation Penetrator, or the NGP, the planned successor to the Massive Ordnance Penetrator. The program traces back through studies such as the 2012 Hard Target Munitions Analysis and a 2019 follow-up, which flagged the need for lighter, smarter, and more widely compatible penetrators. A formal request to industry in February 2024 set technical expectations. By September 2025, the program had moved into the prototype phase. Applied Research Associates, or the ARA, and Boeing won the lead contract, a 2-year effort to design and build both scaled and full-size prototypes. ARA will serve as system design agent. Boeing, the original MOP contractor, will supply integration expertise and a new tail kit to refine delivery dynamics.
This effort will evaluate capabilities against hard and deeply buried targets that pose critical challenges to US national security.
A key design pivot is weight. The Air Force capped the NGP at roughly 22,000 pounds, about 8,000 pounds lighter than the MOP, to widen aircraft compatibility and reduce operational complexity. That opens up use by the upcoming B-21 Raider as well as other long-range strike platforms, improving sortie flexibility and reducing the need to mass multiple heavy bombs on a single aim point. Guidance and fuse technology are central. The NGP must hit within 2.2 meters, even when GPS is jammed or denied, a tight requirement that will lean on hardened inertial systems and alternative geolocation sensors. and fuse advances move beyond floor counting to void counting systems that detect hollow chambers and detonate at the optimal depth, increasing effectiveness while cutting the number of weapons needed. Finally, standoff capability is being prioritized. Glide bodies or rocket motors would let aircraft release the weapon from tens of miles away, keeping crews clear of modern air defense envelopes. In short, the NGP aims to turn the brute force of the MOP into a more precise, flexible and survivable tool for defeating buried threats. Beneath the headlines and satellite photos of craters lies a simple, unnerving fact. Adversaries are digging deeper and smarter. What looked like a solved problem, smash the roof, crumble the halls, is now a chess game played beneath mountains and concrete. That's why the Pentagon is pivoting away from pure brute force and building a toolbox of options to reach what hides underground. First, the hardware is getting a rethink. New alloys, think of a military steel that keeps its edge longer under extreme stress, and terradynamic nose shapes could let penetrators cut through granite and ultra-reinforced concrete far better than older designs. The next-generation penetrator aims to shrink weight while improving punch, so more aircraft can carry it and fewer bombs are needed to finish the job. But raw penetration is only half the story. Modern air defenses and electronic warfare mean guidance must work without GPS. That's nudging designers toward hardened inertial systems and alternative geolocation methods so a bomb still finds its mark when satellites are being jammed. Smarter fuses, the so-called void counting technology, will detonate only when the weapon reaches the most damaging internal chamber, squeezing more effect out of each strike. Then there are non-kinetic and indirect approaches. Electromagnetic pulse and high-power microwave weapons promise to neutralize electronics inside bunkers without punching a single hole in the ground. Fry the circuitry, cut power, sever communication. Programs such as a Troll seek to collapse tunnel entrances, burying a facility under rubble rather than trying to burrow to its core. Thermobaric warheads remain useful for confined spaces, and small kinetic devices that spread fire through subterranean corridors are still on the table. Robotics and autonomy add another dimension. DARPA's subterranean experiments point to a future where small drones, crawlers, and snake-like robots map and infiltrate complexes ahead of, or instead of, violent strikes. They're not a near-term panacea, but they signal how multi-domain this problem has become. For viewers, the message is clear. The next frontier of conflict may well be underground. The MOP proved there are ways to reach deep sanctuaries, but it also showed the limits of a single, massive weapon. The future will be blended. Smarter penetrators, standoff release, electromagnetic tools, and autonomous systems working in concert. That combination, more than any single new bomb, will decide whether underground sanctuaries remain safe or become prime battlegrounds.